Assalamualaikum warahmatullahi wabarakatuh. My name is Noridah Azman. I will present about our introduction. So, the definition of a bridge is a constructed spanning a river, road or railroad to permit traffic to go from one side to the other side. So, the purpose is to make it easier for vehicles to cross existing obstacles. So, any bridge is made up of network of structural components that are arranged to absorb and transfer the force acting on it to its supports. So the bridge is divided by two, which is truss and member. So a truss is a structure part that absorbs and translates the tension pressures, whereas a beam is a structure member that may absorb compression forces. So this project has been made to create a bridge model. So the bridge model requirement is the bridge must be made from statistics and connect with glue or tie, paper thread, masking tape and straws can be used. And then as you guys can see in the figure, overall span length should be exactly 1,200 millimeters. It must be simply supported and there is no deck slab of the bridge. And then height must be 300 millimeters and the width of the bridge must be 100 millimeters. And then the base, it must be 100 times 100 millimeters. And then after the model prepared, it will be tested with the load P placed at the point A and B, and like in the figure, and then slowly increasing load is applied until the bridge fails. The load and the deflection will be recorded. So the objectives of our project is to create a bridge model with maximum structural efficiency possible that can carry load 10 kg load. So second one is to calculate the internal forces of the truss, and the last one is to determine the deflection of the truss. So this is our bridge layout design for the plan view, front view and the side view. And then our bridge design is statically indeterminate with 1 degree structure. Next is bridge specifications. As you guys can see, the above figure is the measurement of each member. So the element of our bridge is firstly the material. The material itself from statistics, connect with glue and tie and thread, and the length of our model is 1,200 millimeters. The width is 100 millimeters, and then the height is 300 millimeters. Number of member used is 18, and reaction type roller and pin support. And then the last one is number of joint, which is 10.
Assalamualaikum and hi, my name is Hidayah Binti Bakar. We will explain about methodology of the project. I will start by sharing to you all the flowchart that shows the process along this bridge project conducted. As shown in this slide, this project was started by the discussion and delegation task of project between the group members. Next, followed by the bridge model stage design. In this stage, the analysis was executed, which are reaction forces and internal forces was determined. Then, the best and efficient design that meet all the requirement was chosen. After that, proceed by the process of build bridge model, and the last procedure was bridge testing. Both of these steps we explain more in the next slide. Finally, the result of load that bridge can accommodate with value of deflection was obtained. Here with me, the list of equipment and material that used in this project of Truss bridge model. For the equipment, hand saw and scissors was used during build a model, while the side load of 10 kg and above and digital balance was used during bridge testing stage. After that, as shown in this slide also, the static straw as connector and all binder material such as hot glue gun, rope, adhesive glue was used in this project. So now I want to share you all on how to build bridge model. Firstly, all of equipment and material that related to build bridge model were prepared. Next, The statistic has been checked first to ensure the statistic in good quality. The member that we create is from 4 statistics was bonded together by tying them with rope and adhesive glue. After that, mark with the dimension as shown in the slide and cut with handsaw. All of the members that want to connect each other must be inserted into straw and was glued by hot glue gun. Then the joint need to build by connect the end of member and glue with hot glue gun again. After the joint already dry, tightly wrap by rope and continue by put a little bit of adhesive glue. After all members completely connect each other, the model will be setting at the place that have higher temperature. Before this, I was explaining about build bridge. In this part, I will continue to share on how to do the bridge testing. Firstly, we take the mass of bridge by use digital balance that continue by the setup the bridge at testing location. The original height was measured from bottom of the floor before placing the load. The load was placed on the bridge model 2 kg each around 30 seconds without collapse. The deflection value was obtained by take the new height. This step will repeat until it reach 10 kg. When it is at 10 kg load, but the bridge model still can accommodate the load and maintain stable, the bridge testing was continued until it collapsed. All of the result was recorded.
My name is Edreena. So next part, the analysis of bridge. There were analysis made by software and manual calculation. I will explain to you first about result analysis bridge using LeanPro software. For software bridge analysis, we use LeanPro to get the deflection, maximum shear force and maximum bending moment. This is because using software analysis can be more accurate than calculated manually. So first, setting up the unit in LeanPro using Newton centimeters and insert the coordinate of every joint and connect every joint together to design the bridge. The supports for bridge is pin and roller and the load was added 15 Newton downward at joint 2 and joint 3. These are the analysis that has been done. The first one is the result of axial force diagram and the second one was the deflection diagram which is give us the maximum deflection of the bridge is 0.04 cm. The next analysis is shear forces diagram of the bridge and the last analyzed by LeanPro is the bending moment diagram that gives us maximum bending moment of the bridge is 27.97 Newton. Next part, my other group mate will explain about manual calculation of the analysis.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hamdan. So the next part, I will explain about how we gonna to analyze and calculate the bridge internal force by using the manual method. So for the first step, we have to draw the idealized model of the bridge to easier the job. So for the next part, I will explain about the determinacy of the bridge before we go through the calculation and also analyze the internal force. We have to know either the bridge is indeterminate, determinate or non-stable. So in this case, we have determined our bridge is static indeterminate with 1 degree. Hence, this truss or bridge is categorized as static indeterminate truss with 1 degree of determinacy, so that we have determined to be used indeterminate truss span method to get all the internal force. In this case, we have determined this truss is internal indeterminate. Because of that, we have decided to redundant member FA to be calculated on real force and put 1 degree of that to do a virtual force. So for the calculation of the real force, we can do many methods. So for my group, we have decided to do the section method and also joint method for the real force. So for this slide, it is example of the section method. So for this slide is about the joint method. The next part is about the calculation of visual force. By using the alternative method, we can get all the visual force with easier and also faster. So for the next part is about the result of internal force by using the manual method. So in this case, we have determined the real force and visual force, and we have to put on the table and then insert the formula like on the slide. So the x value is negative 1.414, and then we have to come with mu and plus the real force to get the actual force. The next point, I will explain about the reaction of actual force at support. After we get all the internal force, we can get the reaction actual at the reaction Ri and also Rd. In this case, we get the Ri is negative 171.49, while the Rd is 271.49. In the design of truss structure, such as roof and also bridge, it is always important to keep the deflection of the truss is to be minimum to maintain the appearance and also functionality of the structure. So in this case, we just measure between the bottom of the truss and also the floor. So we choose the center of the maximum deflection will be occur, and the measurement will be taken before the load is zero and until the deflection is start to be collapsed. This is a table of deflection. From this table, we can obtain the maximum value of deflection is at 23.84 kg and also 21.84 kg until it maintained to 28.84 and before it collapsed at 30.84 kg. So that's all for me.
For the discussion of design bridge, we made bridge with bridge truss. Bridge truss is to transmit load to stringers, then to the floor beam and to the joint. We use for bracing for each member is use hot glue gun, strings and 3-second glue to provide more stability. Second, we make manual calculation and Limpro software calculation. From the manual calculation, we can get zero force member at member BG. Zero force member is used for stability and rigidity of the truss to provide support for various member in under condition. We also know the internal deformation of the truss element. From the LinPro software calculation, we know the moment diagram, shear force diagram, the maximum bending moment. The maximum deflection is 0.0498. That is less than the real testing of deflection. The maximum bending moment is 27.97 Newton. Lastly, from the testing bridge at the lab, it can withstand 28.84 kg of loading before it collapses at 30 kg. There are many reasons that can be said to our success of bridge testing, such as the joint of each member is very the bracing of each member is strong and the structure reach equilibrium state where all the load is transmitted to each member equally. From the collapse, the structure collapsed at 30 kg because the joint is not strong enough and the span is not enough. That's all for me. Thank you.
In conclusion, the bridge testing design build was able to accommodate 10 kg load and above, with the highest load is 28.84 kg. That shows the bridge still sustained. This shows the model is strong structurally. However, the bridge model has been deflected. As shown in the slide, the effect from the deflection, which are increased the stress in members, stiffness was reduced, and directly the service ability will be decreased. All of the effect we made this bridge unsafe due to sway was experienced that's caused by deflection factor. Herewith, I provide some of the recommendations that could be applied during redesign process. Firstly, reduce the length of span because the longer the span, the greater result of deflection will be obtained. Secondly, increase size of the members because can enhance the strength and stiffness. I think that's all for me. Thank you.
So this is the end of our presentation. We will show you our testing video. So thanks for watching and enjoy the video.